Hi there, this is Srikanth Dasari. So in this lesson, we are going to learn about the introduction part to programming with C language perspective. Okay, so it's history, origin, and implementation. Okay, so before diving into that, let me explain a few things. Okay, so this is the first time I'm doing with this marker. So recently I have bought a Wacom tablet and a stylus with stylus. Okay, so my writing would be very ugly, so you need to excuse me for that stuff. Okay, so before diving into the history of C programming language and its origin and its current implementation and various uses, so first let us look what is the definition of a program. Okay, so a program is defined as, okay, so a program, excuse me, so first let me check the brush thing here. Okay, so a program is defined as a program is defined as a set of instructions. So I'm just writing, we're turning very ugly here. Okay, defined as a set of instructions, set of instructions. Okay, set of instructions written, set of instructions written in a language, which is obviously known as programming language. Okay, so set of instructions written in a language which is obviously known as programming language to do a specific task. Okay, to do a specific task or a job. Okay, so this is the very basic definition of a programming program. Okay, so why we need a program? Okay, so you might get why in the world we need to write the programs. You might get a doubt like this. So if you say, if anyone asks you, so what is 2 plus 3? So immediately you will answer that as 5. Okay, so because being a human being, your brain processes this operand 2 and this operand 3, and with the help of this operator plus, which is the sign for addition, it automatically our brain calculates the sum, and immediately we say the output as 5 here. Okay, so to do even this small task with the help of a computer, we can't do it directly as our human brains do. Okay, so we need a program to tell the computer that you need to perform these small operation in the form of a program. So that program can be written either in any programming languages, whether you can call it as a C language or a C++ or Java or C sharp, depending Java or C sharp, and you name it. There are hundreds of languages available as. So depending upon the requirement and thing we are more familiar, and resources and a lot of factors are there to use a particular language. Okay, so entry level programmers and who are more seriously into hardware development and embedded systems kind of thing, they use C programming language to solve their specific tasks or jobs, and also who are more into game programming and object oriented, need more object oriented aspects, who are familiar with object oriented concepts, they go for C++. And also we have Java programming language, which is a big brother to both of the C and C++. Okay, so Java is a more refined object oriented, in some cases it can also be termed as a purely object oriented programming language when compared to C++ or any other older programming languages. So, and also we have C sharp, can also take the choice if you are more familiar into Microsoft technologies. Okay, so Microsoft people only program their applications or develop their applications only using the C sharp programming language. Okay, so language, like how we have English language, set of rules defined into language. So every language like C or C++ or Java has their own syntax. Okay, like how we have in normal real world we have English or Sanskrit or something like that. Okay, so English or Sanskrit, something like that. We have programming languages follow their own syntax depending upon the whoever develops it fix some syntax to that, and we need to obey that particular syntax to write the programs. Okay, so excuse me, let me clear the screen here. Okay, so control N. Okay. Okay, so just in the previous discussion, we have talked about what is a program, what is a programming language, and what are the various examples of programming language available. Okay, so now let us move on to so why we need a programming language. We have just known to write the programs. Okay, so write the programs or to instruct the computer. Okay, so that is the primary purpose, and also another serious purpose of writing programs is to develop a software. Okay, so if you take the definition of a software is defined as a software or an application or whatever you might call is defined as a collection of a software is defined as a software is defined as a collection of programs. Okay, so a software is defined as a collection of programs. Collection of such programs is defined as a software. So what is, now you might get so what is software and all, so on and so forth. Okay, so application software. So primarily softwares is the like applications we use in our daily life here. Okay, so softwares are basically divided into two categories. The first one is application softwares. Okay, so application softwares. So again, I'm apologizing here for my bad handwriting. Okay, so it is very ugly because I'm very new to this stylus and graphics tablet kind of things. And the second one is system software. Okay, so application software and system software. So both these softwares can be written in programming language depending upon the type of application we are developing here. Okay, so system software. Okay, so we will look into detail. So what is an application software, what is system software? Okay, so application software, the typical examples of an application softwares are going to be like Microsoft Word. Okay, so Microsoft Word comma Excel. So you are very familiar with all these things. Okay, so if you have some introduction to computers or school level, you might have been taught all these things. So Microsoft Excel, Word, and PowerPoint, and so on and so forth. So all these come under application softwares. So there are many application softwares examples, not only Microsoft Word and all. So you can take any browsers. Okay, so web browsers, there are many browsers. So browser applications like Chrome and Firefox and so on and so forth, browsers are also called as application softwares, which solve the purpose of web browsing here. Okay, so like Chrome, you have Chrome, very popular, hugely popular and highly performance application software for browsing the websites. Chrome we have, and also we have Firefox, which is mostly used by developers and all kinds of stuff. And also we have Safari. Okay, so from Safari, from Apple. Okay, so browsers are also considered as application softwares. And also we have player softwares like VLC media player. So also, okay, so you can consider media players and video softwares players, or like VLC or Windows Media Player, and so on and so forth. We have a wide variety of choices. Windows Media Player. So due to the lack of space, I'm writing very I'm reading off many words here. Okay, so Windows Media Player or VLC or whatever it might be. Okay, so these are all considered as application software. So browsers are seriously written in a particular programming language, whether it can be a JavaScript or Java. And the world's first browser is written in hot Java. Okay, that is known as hot Java, which is written entirely in Java programming language. Okay, so like this, if you take the programming languages help us, so if without a programming language we can't imagine so developing these wide variety of application softwares. Okay, so when we come to system software's point of view, to say just in a one word, a system software is nothing but an operating system. Okay, a system software is nothing but an operating system. So you might quickly get what is an operating system here. Okay, so let me clear off the screen here and let me go to other new window, control N. Okay, so you might get out what is an operating system here. So we need a detailed discussion of what is an operating system and what are the types of operating systems and what kind of operating systems existed before the evolution of C programming language. And there is a link between birth of C programming language and operating system here. Okay, so it is very essential to learn about what is an operating system here. Okay, so I am giving the definition of an operating system. The operating system is defined as a system software. Operating system is defined as a system software. Operating system is defined as a system software which acts as an interface between a system software. Okay, it is also a kind of software, but it is commonly known as system software, not like an application software, not meant for daily needs. Okay, so it's a overall thing. It's like a platform. So without an operating system there is nothing. So even though you buy a system with 1 lakh rupees like an Apple or Dell or HP, whatever it might be, so you can't turn on that machine and you can't straight away working with that if you don't have an operating system here. Okay, so that is that important for us. Operating systems, which is defined as a system software, is defined as a system software which acts as an interface between an interface between which acts as an interface between user and machine hardware. Okay, so user and machine hardware. Okay, so this is the primary motive of an operating system, which acts as is defined as a system software which acts as an interface between user and machine hardware. Okay, so if you want to work with a machine, or if you want to run all these application softwares, you need to make use of the data, store data, process data, and also do some work related to your daily needs and type a letter or whatever you wanted to do. The first thing you need to have is an operating system. Okay, so in today's world you can name operating systems. We have a wide variety of operating systems divided into three main platforms. The first one is Windows platform. Windows. Okay, the first one is Windows, and the second one is Mac or Apple. Macintosh or Apple. Mac from Apple, Mac operating system. Okay, Mac from Apple. And also we have free stuff known as Linux world is also there. Okay, so these are considered as the three main platforms in this today's world we have. Okay, so Windows, we have starting from Windows 7, 8 and 10 versions. So many versions are there. Windows 7, 8 and 10. Starting from Mac OS, I think we have 10.9 or something like that, which is a good operating systems are there. Mac OS 10.9, some I don't remember the exact code name here. Okay, so since I don't use a Mac. So Linux, we have various distributions like Ubuntu, which is a great operating system. It's one of the greatest thing about Linux is that it is a free operating system. Okay, so we have Ubuntu and Red Hat, which is an enterprise. It's not free, we need to buy for that. Red Hat Enterprise. Okay, so Red Hat Linux is there for that, for enterprise purpose, to solve the enterprise server level editions. Okay, so Ubuntu has also client edition and also server edition. Ubuntu comes with a desktop client edition for normal users, and also it has a server editions to run all the server applications. Okay, to solve the server needs. Okay, similarly Red Hat also has a client edition and also a server edition, and so on and so forth. Okay, so this is about the operating systems. Okay, so next we need to know So what is the, just we have learned about the operating system here. So let us go more into deep and how this operating systems has related to the birth of C programming language. Okay, excuse me. Okay, so in today's world, we have all this as in the previous discussion, we have learned that in today's world we have all these operating systems like Windows 7, 8, 10, and all. Okay, so actually the birth of C programming language took place in the year 1972. Okay, so 1972 uh, by a gentleman known as Dennis Ritchie. Okay, by a gentleman known as Dennis Ritchie is a great gentleman who worked as a scientist in by Dennis Ritchie at the rate AT&T Bell Labs USA. AT&T Bell Labs AT&T Bell Labs USA. Okay, so Bell Labs, the many innovative things, groundbreaking inventions were made in AT&T Bell Labs USA, like C, C++, Unix operating system, and you name it. There are many innovations has taken birth here. Okay, so this is like a pilgrimage for any computer programmer or developer, a holy place you can call it. Okay, so Bell Labs USA. So back in 1972. Okay, so now I am here. We are in 2016. I am doing this recording in the year 2016, which is exactly some 44 years, if I'm not wrong, years back. Okay, so in those days, okay, so the world of programming doesn't start with the C language. Okay, so C language, before C language also, the people used to program. Okay, so there are many languages before C language. Okay, so there are the primarily all those programming languages back in those days and today also divided into three main categories. Okay, the first one are high level languages. Okay, the first one are high level languages. The first one are high level languages. Okay, and you need to excuse me for my bad and ugly writing here. Next, the second one is low level languages. Okay, so low level languages. Second one is low level languages, and third one is machine language. Okay, third one is machine language. Machine language. So these are the three classification of programming languages. Okay, so based on the levels or their capabilities. Okay, so machine languages or machine language. Let's not say machine languages. Let me take eraser. Sorry for wasting your time. So machine language. Okay, so let us do a detailed discussion about each and every language here. So what each and every level of language here. Okay, so let's do a detailed discussion. Okay, so first one is high level language. Okay, so what is high level language? If anyone asks you, so high level languages are designed. Okay, a high level, the name itself. Okay, so high level languages are designed high level languages are designed with are designed for a specific purpose. Okay, so they are not designed to solve all the needs of a programmer, and all kinds of applications, different kinds of applications cannot be developed by using a single high level language. Okay, so high level languages are designed for a specific purpose. Okay, for a specific purpose. So we will list what are the high level languages available before the birth of C language for a specific purpose. Okay, so all the high level languages follow a principle. Let's take it as a second point here. Okay, so all high level languages follow a principle of do more with less code. Okay, so the main advantage of high level language, okay, the all high level languages do more with less code. Okay, so you need not write lengthy code as we do in low level language or machine level language. Do more with less code. Okay, less level of instructions, less memory, so everything high performance, everything comes with high level language. Okay, do more with the less code. Okay, so if you want various examples of high level language before 1972, so I'm talking about before the birth before 1972. So what are all the high level languages? If you want, you can list out here. Okay, so before 1972, the high level languages are like this. The first one is okay, so before Fortran. Okay, so one second, let me take the eraser once again. The first one is Fortran. First one is Fortran from IBM. Okay, so Fortran is uh, uh, designed by IBM. Okay, it's all the world of programming is seriously started with the Fortran. Okay, and then it uh, gave way to Algol. Okay, so these are the Algol is another high level language. So people are happily programming in all these languages, and then we have COBOL, and then we have COBOL, and also we have Pascal, and so on and so forth. Okay, so there are plenty of languages available before the birth of C language. Okay, before the birth of C language. So Fortran is designed by IBM, which is the primary goal, or it's abbreviated as formula translation. Okay, so it is abbreviated as formula translation. Okay, so it is also used only by scientists and engineers, and not designed for all multi-purpose. Okay, it's not designed for multi-purpose. And also Algol is a language designed for algorithms. Okay, so Algol is a language designed for developing algorithms. Okay, so Algol is defined for algorithms. And also we have COBOL, which is a business oriented language. So back in those days, like how we have in these days, we have Tally and Excel spreadsheets, and so on and so forth. We have business oriented languages. It's also known as a business oriented language, only for specific purpose of business oriented things. And also we have Pascal, which is a general purpose programming language, not like C, like C before C, but it's also not that good. Okay, to do to develop all the applications. So Pascal is another general purpose programming language. I'm running out of space here. Let me clear the screen once again. Okay, so we have let me write all those things here once again. So first one is Algol, very high level language. So why we are discussing all these high level languages? Because Algol and or let me write Fortran. So all these things, because there are the drawbacks in these programming languages has made the developers of C language, Janice Ritchie and Ken Thompson. Okay, so to develop a new kind of technology which is portable. Okay, so Fortran and COBOL and Pascal and so on and so forth. So they are all good at their specific purpose. Okay, so not for not for multi-purpose. Okay, not for cross platform. Okay, so not for independent. Okay, platform independency or cross platform or multi-purpose. They are not multi-purpose programming language. Okay, so whatever the things that could be done in Algol could not be done in Fortran. Okay, whatever the things that can be done in Fortran could not be done in COBOL, and vice versa. Okay, so Pascal is also the only things that can be done in Pascal are done in Pascal only. So rest of all other programming languages cannot perform the things which are done in Pascal. So this is the main drawback of using a high level language. Okay, so they are highly independent of one another. So what they have done is the people at AT&T Bell Labs, as we have discussed previously, AT&T Bell Labs, so who are looking for a new kind of technology, so they have uh, turned their attention to low level languages. Okay, so high level languages they have looked to develop applications, so which is not that easier to adapt a high level language for developing low level applications. So what they have done is they have turned their attention towards low level language. Okay, so low level languages. So one of the best example of low level language is assembly level language. Okay, so the only low level language existing is assembly language. So what is assembly language? You might get out here. Okay, so assembly language is nothing but the language of the microprocessor. Okay, so every microprocessor chip. Okay, let us say that 8085 or very first microchip is Intel 404 or 8085 or 8086 or 8086 888 8 0086 or like Pentium. So in the back in those days we have Pentium and all Pentium processors. So now they are calling it as Core i3 processor, and so Core i3 i5, and they are calling like that. So each and every processor has its own assembly level language, which is nothing but a set of instructions called mnemonics. Okay, so they are embedded. So whatever the assembly level language you are learning for 8085 for say, which is 8-bit microprocessor. Okay, which is a 8-bit microprocessor. It has its own set of mnemonics and registers based on that architecture. And also we have 8086, which is a 16-bit processor. 8086 is a 16-bit processor, and it has its own assembly level language and registers based on its architecture. And starting from Pentium 4 and all so on and so forth, i3 and i5, these are all i3 i5 are all 64-bit processor, which has more processing capabilities. Okay, so which have more processing capabilities than the previous 8-bit or 16-bit processors. Okay, so low level languages, we have assembly level languages which are very highly processor specific. Okay, processor specific, and they don't have any portability. Okay, so the applications which are developed with the assembly language, with using the assembly language of 8085 cannot be used in another architecture, let's say 8086. Okay, so one second, let me clear the window. Okay, so there is a link between these levels of programming languages and low level we have just learned about high level language, low level languages, and machine language we haven't yet learned here. Okay, so but what they have done is, so let's see about machine level language also. So what is the machine language? The machine language is the only language. So machine language. So at the end of the day, the processor sitting in your CPU understands only machine language. Okay, so machine language is the only language. Is the only language. So only language understood by the machine language is the only language understood by the system. Okay, system or processor, whatever it might be. Okay, so machine language just consists of nothing but zeros and ones. Okay, so you might think that so what is the use of writing all these learning all these programming languages which are not understood by the machine, and why can't we write directly programs in the machine language? You might get some kind of doubt like that, but it is not correct. We can't write for normal human beings, it is impossible to write. Okay, for normal human beings it is impossible to write programs in machine language, because humans cannot interpret all those ones and zeros, and it takes ages, and the length of the code gets increased dramatically. Okay, so it is impossible to write programs, write impossible to write programs in machine language. Okay, it's impossible to write programs in machine language. They are very hard to debug. Even though we manage to write programs, they are very hard to understand and debug. Okay, so hard they are. Even though somehow we manage to write the programs, it's very hard to understand and debug. Okay, very hard to understand and debug. Okay, so these are the drawbacks of machine language. So it's very quite impossible to write programs in machine language, and they're very hard to understand and debug the programs if there are any errors or exceptions occurs. Okay, so these are the various levels of programming languages. Okay, so there is a connection between the operating system and these levels of programming languages and the birth of C language. So let's now see that how they are connected. Okay, so we know that the programming languages, just we have discussed, devised or categorized into three levels. The first one is high level languages, and the second one is low level, and the third one is machine language, which is only understandable by the machine. Okay, so these are the three levels of languages. Okay, so operating systems, as we have discussed that in today's world we have Windows and Linux and Mac OS. Back in before 1960s, late 60s. Okay, so late 60s and early 70s, late 60s and early 70s, we have only one operating system which is dominating the world, and the IT industry is Unix operating system. Okay, so Unix was also designed by this great human being, Dennis Ritchie, who is also considered as father of Unix and also father of C. Okay, so Dennis Ritchie, the person who is responsible for designing the Unix operating system. Okay, so Unix operating system is the only operating system which is existed. It is dominant in those days. Okay, so dominant operating system in those days. Dominant operating system. Okay, so the problem with the Dennis Ritchie, who is the father of Unix operating system, has observed that there is a problem with the Unix operating system which was written. The only problem with the Unix operating system is it has designed using the low level language. Okay, so Unix operating system at that stage at the beginning was written entirely in a low level language. So just we have discussed it. The problem with the low level languages are they are very processor specific. Okay, so they are I'm reading professor here. Excuse me. Take an eraser. Very new to all these kind of things. A lot of practice is required heavily. Okay, so they are processor specific. Okay, so the only problem with developing applications with or operating systems with low-level languages before the birth of C, so they have only choice. They have checked with high-level language, since they are very applications are specific. They are designed with the purpose of specific goal, and also they can turn around and design the operating system in a machine-level language, because it consists of only ones and zeros. Okay, so as we have learned that machine language only consists of zeros and ones. So machine language consists of only zeros and ones. Okay, so in today's world we have, if you want to develop any if you want to download or install any software, it's just a matter of seconds for us. Okay, it's just a matter of seconds. We just go to internet and download whatever the software, and using if we take the help of internet. Okay, we take the help of internet and we download whatever the software we require, and internet, and download and install. Okay, it's just a matter of seconds, and depends upon the speed of our internet, we can internet download and install. Okay, so back in those days there were no USB drives, or else if you go this path, or else you can go to a friend, or in today's world if you take a USB stick, or CDs are already outdated. No one is going to use CDs and so on and so forth. So you can take a software from in a USB stick, and you can plug into your computer, and you can plug in and install. Okay, so this is in today's world, all these things are possible, but back in those days we don't have plug in install. Okay, plug in and install. So back in those days, back in those days means before 1970s, there are no USBs and no internet and everything. So to write a small program itself takes a day or a week. Okay, so to develop a small program itself takes a day or a week. Okay, so imagine, so if you want to develop operating systems using machine language in those days, where we don't have internet or USBs or CDs and so on and so forth, it might take years and years. Okay, so if anything goes wrong, they need to do the whole process from the beginning. Okay, from beginning they need to do the whole process from the beginning, and this is going to be the never ending process. Okay, so and also so that for that reason they never adopted they never written operating systems or develop applications using directly using the machine language. Okay, then they are only left with low level language like assembly level language. That's what they have done before 1970s, a birth of C language. Okay, so but there is a problem here. So let me take again a new window. So in the previous discussion we have learned that. Okay, so from the previous discussion, we have learned that back in those days, the only dominant operating system in the industry is Unix. Okay, so Unix was designed before the birth of C entirely in low-level language known as also known as assembly language. Okay, so assembly language. Okay, so we have learned what are the drawbacks of assembly language, which is the main drawback of assembly level language. It is very no doubt that it is assembly languages are very highly powerful, and in terms of speed of execution they are also good when compared to some high level languages. But the only problem is they are processor specific. Okay, so specific processor specific. Okay, processor specific and lack of compatibility. So sorry, lack of portability. So lack of portability. So another important term here. Okay, so portability. So you might get what is the meaning of portability. So portability means, so whatever the platform or whatever the operating system you are giving, that application should run in that platform. Okay, so you might so C is highly portable language. If you want to define a C language within a one word, you can say it is a portable language. Okay, so C applications, the programs written in C will run on any platform. So applications developed on C. Okay, so with just a minor or no changes, you can run the C programs on any platform, on any architecture, even though on embedded devices also. Okay, so lack of portability, process specific, and lack of portability. So these are the two main drawbacks, and they have for example, if you say they have ported Unix operating system, so they have given a new Unix operating system, so for a huge machine like HP or IBM. Okay, so which uses the different which uses different architecture and different architecture. What they need to do is they need to design new Unix operating system based on the processor architecture of the HP machines, and also they need to rewrite the entire operating system again using the IBM's architecture or IBM's processors assembly level language. Okay, so if tomorrow some digital equipment corporation, so these are the companies which were existing before. So nowadays we have Microsoft, IBM, and Apple and all those things, but in those days, so these are the only major players. So if tomorrow some DEC comes, digital equipment corporation, and again they have to give the Unix operating system based on that architecture. So like this they need to change or rewrite the entire code again and again based on the new architectures and so on and so forth. So finally they felt that they are going in a wrong direction. Okay, so this is a very wrong direction, wrong indication. So they keep on doing that, this is not a good way to do. Okay, because so operating system must be unique. Okay, so it should run on all architectures. So whatever the architecture you give, so if you port that operating system into that architecture, it should run independently. Portability, so that is what we call portability. Okay, so keeping that in mind, what the Dennis Ritchie, the developer, the father of C, is designed. They have designed a C language. Okay, so they need a new technology which is very highly portable. Okay, they need a highly portable, the new technology which is highly portable. Okay, not processor specific, not processor specific. It should run on any architecture. Processor specific, not processor specific, not dependent on hardware, not depending on hardware. Okay, so they need to develop a new technology from the ground up, okay, or taking inspiration from other technologies, not depending on any architecture, So what they have done is giving architecture. Oh, my handwriting is ruining here because of this new device, very new, just 4 to 5 days of using this. Okay, so new, not depending on any architecture and so on and so forth. So they have began developing C language from back in 1969. Okay, so 1969 they have kept all these goals and started developing C. Okay, started developing C from 1969. So finally started developing C. So finally by 1972, so the technology has become such a huge popular that the Unix operating system, by 1972 the Unix operating system, Unix OS, was rewritten entirely. Let me take the eraser. I'm sorry for ruining my handwriting here. So they have the entire Unix operating system, brush, was rewritten in C, was rewritten in C from assembly language. Okay, rewritten in C from assembly language. Okay, so this gave by this task, the Unix operating system will run independently on any architecture. Okay, so it had gained they have added portability. Okay, so by rewriting the Unix operating system in C language, they have added more portability, and the C began running the same operating system began running on different architecture. Okay, so let me take a new window, filled up space here. Okay, so Unix operating system Unix operating system became portable. Okay, so Unix operating system became portable when designed on C. Okay, so portability by adding this portable feature, Unix became hugely popular in the industry. So Unix became hugely popular in the industry. And so how they have so everybody started paying attention. So how the scientists or engineers done this thing, so they have turned their attention to C language. Okay, so initially Unix is responsible, so in that way Unix is responsible for popularity. So Unix is responsible for the popularity of C language. So Unix is responsible for the popularity of C. Okay, and C in turn is responsible. Okay, let me take the eraser once again. Okay, and C in turn is responsible for the popularity, and C in turn is responsible for popularity of Unix. Okay, so C in turn is responsible for the popularity of Unix. Okay, so both the C language and Unix operating system has helped each other for gaining the popularity. Okay, so both C language and Unix operating system helped each other by by rewriting the Unix operating system using the C language. Unix has became portable and began running on all different architectures with an ease. and all of a sudden all the industry people have gained attention towards the Unix operating system, and they have learned that they have the scientists and developers done using the C language. Okay, so done this task using the C language. Okay, so this is all about the history of C language. So how it became hugely popular, and so what made the birth of C language. Okay, so what made the birth of C language very popular, and so on and so forth. Okay, to summarize once again, whatever we have learned all. Okay, so what is a program? We have learned the definition of a program. So what is a program? A program is nothing but a set of instructions written in a particular programming language to do a specific task. And also we have learned what are the various classifications of programming languages. Okay, so classifications in terms of levels. Okay, classification in terms of levels here. So they are high level language, low level language. Okay, so high level languages, programming languages are divided basically into three categories. The first one is high level languages. high level High level languages, low level and machine level languages. High level language, low level language, and machine language. Okay, so and also we have learned about what are the types of so collection of softwares is collection of such programs is nothing but software. Okay, so collection of programs is nothing but a software. A software is again designed or categorized into two major classifications. The first one is application software. The first one is application software, and second one is system software or operating system. The second one is system software or operating system software or OS. Okay, so and also we have learned about the connection of these all these things, and the birth of C language. Okay, so operating system is played a very important role. The in the beginning, back in 1970s, the only operating system which is very dominant in the industry is Unix operating system. The problem is the early version of Unix operating system was written in the early version of Unix was written in assembly. Early version of Unix was written in low level language. Was written in low level. Oh my god, I am ruining my handwriting like anything. You must excuse me for all this bad and ugly stuff here. Okay, so earliest version of Unix operating system was designed using the low level language. Okay, so designed using the low level language. Let me strike it off and write here low level language. Okay, so low level languages like assembly language. Okay, so low level language like assembly level language. So they have identified the developers of Unix operating system, who are also supposed to be the father of C also. So Dennis Ritchie has identified this is not a good direction to go. The industry must go. So they switch the gears immediately, and they have developed a new technology which is highly portable. This led to the development of a new technology portable, which is highly portable, known as C language. In that way, the birth of C has happened. Okay, so see you in the next lesson. Hope this tutorial has helped you. Give a thumbs up if you like it. So goodbye.